All right, guys, so we are looking at page 233 in our Big Ideas Journal. So first of all, a partial sum, we want to know what that means. A partial sum is the sum of the first n terms in a series. The sum of the first n terms in a series. So we're going to look at a series. Let's say we've got this. We're going to be looking at a geometric series like, let's go 1 plus 2 plus 4 plus 8 plus 16 plus ... When we see this ... this means that it's an infinite geometric series. The reason it's geometric is because I'm multiplying by a value over and over. And what is that R value that I'm multiplying by? 2. Now, what's going to happen to this sum if I just keep doing this? If I add 1 plus 2 plus 4 plus 8 plus 16 plus 32, what's going to happen to that sum? Yeah, it's going to keep getting larger. It's going to go up without bound. It's just going to get larger and larger and larger and larger. So when I have a series like this, an infinite geometric series where this R value is greater than 2, there's going to be no sum. There's no sum. And the reason why is because it's actually infinite. Now, I can talk about partial sums for this. I can do S sub 2, which S sub 2 would just mean the sum of the first two terms. So S sub 2 just means 1 plus 2, which is 3. So what's S sub 4, you guys? No, S sub 4 means the sum of the first four terms. It's going to be 15. Okay, so that's what these mean. When you see S of 2, that means the sum of the first two. S of 4 means the sum of the first four. It does not mean A sub 4. See, A sub 4 means what is the fourth term. So the fourth term here, and it would really need to be a sequence rather than a series separated by commas. But if it had been a sequence, then it would have been that A sub 4 would be 8. So see the difference there? So if you look at this formula, this is for the sum of an infinite geometric series. And here's what it is. This geometric series had no sum. But the reason it had no sum is because the absolute value of R is greater than or equal to 1. When that happens, there will be no sum. It's going to go up and up and up without bound, and it's going to be infinite. But if the absolute value of R is less than 1, we do have a sum. And this gets a little confusing to people. But let's look at this pattern now. So this was our first example. Let's look at this example. Suppose we have 2 plus 1 plus a half plus a fourth plus an eighth plus a 16th, ... This will have a sum. Here's how I know. Even though it goes on forever, what happens is the amount that I'm adding on is negligible. It gets so tiny that it doesn't even change our sum. Because if I add on 0.000001 to something, it's not really changing the value of it. So to find the sum, first I find the R. I can do that by doing A sub 2 divided by A sub 1, or A sub 3 divided by A sub 2. R is 1/2 here. To find the sum, it's right here. It's going to be A sub 1, here's A sub 1, over 1 minus 1/2. So it's going to be 2 divided by 1/2. So it's 2 times 2, which is 4. And I know that that's kind of mind-blowing for some of you, because you feel like it should just keep getting larger and larger and larger and larger. But watch, guys, even if I do this on my calculator, look at how this just kept getting larger without bound. But if I do 2 plus 1 plus a half plus a fourth plus an eighth plus a 16th, I'll go as far as it's somewhat easy, plus a 32nd plus a 64th. Oh, shoot. I didn't do a plus, did I? Plus that, plus this, plus 1 over 128, plus 1 over 256. I'll stop there. Watch what I get for my answer. What is that pretty darn close to? 4. And guys, if you sat here and did this until 5 o'clock tonight, just kept adding these on, eventually the calculator is going to stay at 4. It's going to say 4 and it's going to stay at 4 because it gets so close to 4 that it runs out of digits. Once it gets to 3.99 with all these filled up with 9s, which it eventually will if we kept doing this long enough, then it's going to just start saying 4. And that's the reason why these have a sum, whereas this did not have a sum, because our numbers kept getting larger and larger and larger. Okay? All right, so let's try some other ones now. Flip over to the next page. Your book is going to have you do some graphs. I don't care about you doing the graphs. It's not really that important. So let's go over to number 3. So it says to find the sum of the infinite geometric series if it exists. By looking at this problem, I can see that it is going to be an infinite geometric series because it says that n is going to go from 1 to infinity. So therefore, it is going to be infinite. If I want to find my first term, a sub 1, I plug in 1 for n. 1 minus 1 is 0. Anything to the 0 power is 1 times 6 is 6. My second term, I plug in 2 for n. 2 minus 1 is 1 times 3/5 raised to that, and that's going to give me 18/5. So here's what's going to be happening. I'm going to have 6 plus 18/5. Then I can plug in 3. That's going to be 2. If I square that, 9 over 25 times 6 is going to be 54 over 5. Plus dot, dot, dot. It's going on forever. So in this case, what is our a sub 1? What's a sub 1 here, guys? What's our first term? 6. And what's our r value? What is this divided by that? Or in other words, what do you multiply this by to get that? 3/5. So r is going to be 3/5. So then to find our sum, we're going to have to do a sub 1 over 1 minus 3/5. I can grab a calculator, or we can do that in our head. It's not that easy, or not that difficult. 6 divided by 1 minus 3/5 gives us 15. So this sum would be 15. Okay? And the reason I knew that it had a sum is because this r value is less than 1. So in this problem, we're not going to do this whole problem, but I just want you to tell me what's a sub 1 and what's r. Now, guys, be careful when you find a sub 1. A lot of people say, oh, okay, a sub 1 was 6, and r is 3/5. So that's always going to work. A sub 1, 6, r 3/5, a sub 1, 10/3, r 5/2. Well, it is true that r is always going to be this. That's true. But this could change, because if this had just been to the I power, instead of being to the I minus 1 power, then our a sub 1 would be something different. Our a sub 1 would actually be, if that minus 1 wasn't there, 5/2 to the first is 5/2, it would be 50 over 6. which reduces to 25 over 3. You see what I'm saying? So a sub 1 needs to be checked. R is always going to be this, though. Okay? So we can stop there on that one. I want you guys to do number 5 on your own. You should get 15 halves. Everybody get it? A sub 1 was 5, R was 1/3. And go ahead and do the arithmetic. 5 divided by 2/3. Okay, let's do this one real quick. A sub 1 is 1/2. R in this case, what's R going to be in this case? It's not just 1/2 though. Negative 1/2. And that's okay. R is allowed to be a negative 1/2. Our formula says that the absolute value of R has to be less than 1 to use the formula. And so this will have a sum. So to find it, I do 1/2 a sub 1 divided by 1 minus negative 1/2. Be careful if R is negative that you do minus the negative. Okay? So this is going to be 1/2 divided by 1 plus a half is 3 halves, so I have 1 divided by 3 halves, so that's going to be 1/2 times 2/3, and so this is only going to be 1/3. And here's what I do. Like if I'm taking a test or something, I would now kind of check this just by doing what's even written there. If what's written there isn't close to 1/3, I'm going to do just one more. If it's not close to 1/3, then I know that my answer is wrong. And that's not super close to 1/3, but if I did a few more terms, it's going to get closer and closer to 0.33333. And if you did it all day long, it eventually is going to say 0.3 repeating. Okay? All right, number 7. A child pushes a tumbler toy and lets it swing freely. I don't know what a tumbler toy is, but it's something that obviously swings. So on the first swing, the toy travels 30 centimeters. So it's going like this. It swings, goes 30 centimeters. On each successive swing, the toy travels 75% of the previous distance. So now it's going to go about like that far, and then it's going to go about that far, and then 75%. So it's going like this. Okay, so eventually it's going to get so that it's still theoretically moving, but it's such a small movement that we really don't count it. So we can use the formula on this. A sub 1, what is it? 30. What's R? What's our ratio? What are we multiplying by? 3/4 or 0.75, whichever you prefer to use. And now we just use our formula. So the sum's going to be 30 over 1 minus 3/4. So 30 divided by 1/4, which is 30 times 4, which is 120 centimeters. So it's going to travel pretty far before it gets to the point where it's just barely moving and not really affecting the distance in any way. Have you guys ever seen those things that like you move it once and it just keeps going, it never stops moving? Do you guys know what I'm talking about? They're like little bobblehead almost like things. I don't know, Miss Gadoff has a couple of them on her desk if you ever have her, but yeah, I don't know why they never stop moving. It's not like there's any motorized thing in them, but the way they're balanced, like they just keep going. But they go the same distance. Like if they ever went less of a distance, then eventually they would stop moving, but somehow it's weighted so that it always goes the same distance, so it never stops. I don't know. Kind of interesting. All right. Write 0.121212121212 as a fraction in simplest form. Here's what this is actually, what this is equal to. this is equal to 0.12 plus 0.0012 plus 0.000012. It continues in this pattern forever. 1, 2, 3, 4, 5, 6. That's what it is. That's what this is equal to. So it's really a summation. We're adding all of these numbers. We're adding these numbers forever and ever. So what I can say then is I can find this sum. They're asking us to write this in a fraction in simplest form. Well, I know what that this is the sum of all these numbers. So a sub 1 is 0.12. R, we're going to have to do 0.0012 divided by 0.12. I can multiply the top and the bottom by 100, or I can just grab a calculator. That's going to be 0.01 for R. So I'm going to have 1 minus 0.01. So this sum then is going to be 0.12 divided by 1 minus 0.01 is 0.99. This is pretty easy. Just multiply by 100 on top and bottom, and you get 12 over 99. And what's that going to be in lowest terms? 4 over 33. So if I want to check that, I want to see, is 4 over 33 really 0.12 repeating? 4 divided by 33, and it is. And it would go on forever if the calculator could. Calculator's programmed so it only goes out however many digits, maybe 10 I guess it is. All right? So that would be that as a fraction in lowest terms. Do you guys know these decimals? 1 over 9, do you know what 1 over 9 is? 0.1 repeating, right? What's 2 over 9? Repeating. 3 over 9 is 1/3. 0.3 repeating. So this pattern, it holds true for all of these. So do you know what's going to happen at the end then? What's 9 over 9 then? 0.9 repeating. 9 over 9 is 1. So is 1 the same as 0.9 repeating then? It is. 0.9 repeating is the same thing as 1. And it has to do with that thing that I was talking about, that it's so negligible, the difference is so negligible that we can say that 1 is 0.9 repeating. And it's all based off of this. If this pattern holds true, then this must be true as well. Okay? All right, guys. So your homework's on the board, page 439. You guys can start on that. You still got about 17 minutes.